Propagation of uncertainty in measurements. Anytime when you make a measurement, you're going to use tools to do the measurements, and there's going to be uncertainty in the measurements, and they will propagate through calculations, and they'll give you an uncertainty in the measured values. All right, on the next slide, we're going to look at what is uncertainty. All right, so let's get some idea about uncertainty. All right, let's say that you want to measure the length of something. So let's say you measure the length, like say 25 centimeters. Now the question is, let's say you use a meter stick to measure that. Okay, so the meter stick has an uncertainty because the least amount it can read might be a millimeter, which is about a tenth of a centimeter. So I will write this as 25 centimeters plus or minus 0.1 centimeters. All right. So here 0.1 centimeter is the uncertainty. Okay. All right. So if I call this a length, I will say L plus or minus delta L. So delta L is the uncertainty, and we write it like L plus or minus delta L. Okay. So if we just want the uncertainty, then delta L is the uncertainty. All right. Now there is no plus or minus for that because it's absolute value. The plus or minus goes when you write that as L plus or minus delta L. So delta L itself is a positive number. It tells you by how much the number could be off, could be high or low. In the case of a meter stick, it might be 0.1 centimeters. Now you could measure length more accurately with other devices. There is the vernier caliper we have. So if you use a vernier caliper, you could measure things down to 0.01 centimeters. All right, so let's say that you measure something, in this case, say 2.55 centimeters. So in this case, the way you write that will be 2.55 plus or minus 0.01 centimeters. Okay, so the uncertainties are different depending on what instrument you use. Okay, on the other hand, if we use a micrometer, the uncertainty might be 0.001 centimeters. Okay, so if you measure something with that, you see the uncertainty goes down. So that's the idea of uncertainty. And then the next thing also you need to understand, so this number here is just the uncertainty, but if you want percent uncertainty, what is percent uncertainty? Well, to get the percent uncertainty, what you do is take the uncertainty, say delta L, divided by the length L, and then of course if you want the percent, you multiply by 100. Okay, now if you don't multiply by 100, you get the fraction uncertainty. All right, but if you multiply by that, you will get this anyway. So that's the difference between uncertainty, percent uncertainty, and of course if you want fraction uncertainty, it will be just delta L over L is the fraction uncertainty. Okay, so these are some useful terms when we go forward and talk about other stuff. All right, let's say that I like to figure out the uncertainty in the area and the perimeter of the rectangle. All right, so let's say that I have a rectangle whose length is say L, width is say W. So the question is, what is the uncertainty? First of all, we need to know what's the uncertainty in the length and what's uncertainty in the W. All right, it could be 0.1, 0.01, whatever, but they'll give it to you. So I'm going to write this down as, all right, I'm going to use a red color here, so it'll be easy. So let's say that L is, I'm going to write the length as L, all right, plus or minus delta L. And for the width, I'm going to write it as W plus or minus delta W. Okay, so basically delta W is uncertainty in the width, and delta L is uncertainty on the length. All right, okay, so let's calculate the area first. So what's the area? Of course, area is length times width. Okay, so use the given length and the given width, you can calculate that. All right, so you know you may have a value for that, but the question is then, how do we figure out the uncertainty in the area? All right, so let's say okay, so So let me give you some numbers. So let's say that L is all right. So let's say L is say 10 centimeters plus or minus 0.1 centimeters. Okay, and width is, let's say, is 5 centimeters. But let's say this one is plus or minus 0.05 centimeters. Okay, so a little bit less than 0.1. All right, so now to figure out the area, I'm going to use just the length and the width. Okay, so 10 times 5, so I'll use just 10 times 5, so that'll be 50 centimeters squared. Okay, but the question is, what do I put for my plus or minus here, right? So that is going to be my delta A is the question, because delta A is going to be the uncertainty I need to put there. All right, so the way we calculate this, in the case of multiplication, uh, to find the uncertainty, what you do is basically you add the percent uncertainties. All right, so here's the formula for that. So delta A over A is equal to, you take the delta L over L plus delta W over W. So this will give you the fractional uncertainty for the area anyway. So you can just calculate these numbers. You have all the number. Delta L is 0.1 over 10 plus delta W, we have 0.05 over 5. So if you calculate all this, you will get the answer for delta A over A. And then if you want delta A, just multiply by the area anyway. All right. So let me see. This will be point, we divide by 10. Okay. So 0.01, I guess. All right. And then this will be also, if you divide by 5, you get 0.01. So this gives you 0.02. Okay. So what we got is, let me go up a little bit here. So what I got is delta A over A is 0.02. So if you want just the delta A, all you had to do is you multiply by A here. Okay, so 0.02 multiplied by the A, which we figured out earlier, which is 50. So that's the answer here. So if you calculate this, I think you're going to get, let's see, if you multiply this 0.02 times, okay, I moved as well, okay, I believe it's 1. I think it's about 1 here anyway. So let's see, 2 times 0.5, yeah, 1. Okay, so the answer is, for the A, I will write it like this. Okay, so basically the delta A is 1 centimeter squared. Okay, so if you want to write the area with the right uncertainty, the way you write that is, let me say different color for the final answer. You will say 50 plus or minus 1, and of course that's in centimeter squared. All right, so that's the way you figure out the uncertainty in the case of the area. Now let me erase this and show you how do you figure out the uncertainty for the perimeter. All right, okay, so what's the perimeter here? Well, the perimeter is going to be length plus the width plus another length plus another width. Okay, so that's the perimeter. All right, so I have L plus W plus L plus W. So that's the perimeter. All right, so I will call that as P. Okay, so my question is, how do I find delta P? Okay, now when you add or subtract to find the uncertainty, what you need to do is you need to add the uncertainties. All right, so let's say the uncertainty for the L is plus or minus delta L. So actually the uncertainty value is just delta L, and this one, let's say, is delta W. Then in this case I need to add the uncertainties. All right, so I'm going to put the, so for the delta P, because I have an L here, so I will do the uncertainty for that plus the delta W plus another L I have, so you put another delta L plus another delta W. So the uncertainty will be 2 delta L plus 2 delta W here, okay, because you're using 2 times. Okay, so once again, if you use the earlier number I gave you, I think I gave you L is, I believe 10 plus or minus 0.1 centimeters. And for the width, I gave you 5 plus or minus 0.05 centimeters. So if you use these numbers, um, okay, so the delta L is 0.1, all right, so you do 2 times 0.1 plus delta W is 0.05, so use 0.05, okay, so that's the answer here. So if you do this, you are going to get 0.2 here plus this will be 0.05 times 2, that will be another 0.1, I think, so you end up with a 0.3, all right, okay, so that's the delta P. Now let's calculate P. All right, so we are going to add two L's. So L is 10, so 10 plus 10, 20, 5 plus 5. So basically we'll get 10 plus 10 plus 5 plus 5. So that'll be 30 centimeters. All right, so the answer will be 30 plus or minus 0.3 centimeters. So that is the perimeter here. All right, so that's the way you figure out the error for the um, perimeter and the area for a rectangle. All right, so when you add or subtract, you just add the uncertainties. All right, when you multiply or divide, you need to add the percent uncertainties. All right, so let me show you another example here. So next one, what we have is we like to find the uncertainty in the density in the case of a cylinder and also a rectangular solid or cuboid. Okay, all right, so the question is, what is density? Well, density is mass over volume. All right, now in the case of a cylinder, the volume is going to be pi r squared h, okay, where r is the radius, h is the height. In the case of cuboid, we have length, width, and height. So the volume will be length times multiplied by width multiplied by height. All right. And then of course we also have the mass, so we need to have some uncertainty in these values. All right. Now about the mass, depending on how you measure it, if you use a scale to measure the mass, the uncertainty might be 0.1 gram or it could be 0.01 gram depending on the scale you used. Okay, so this will be the delta M. All right, so that's the delta M here for the, okay. Now the length and the width and the height, let's assume that we used vernier here in this case. All right, so then the delta L is equal to, I think if you use a vernier, it will be 0.01 centimeters. All right, and then the same thing for delta W also, so you can use 0.01 again if we use the same thing. And the height also, we use the vernier, then it's also the same anyway, so you can use always 0.01 if you use that. In case if you used a micrometer for one of them, you may want to use 0.001 for that. Okay, but I think we'll make it a little bit easier here. Okay, so now how do we calculate the uncertainty in the density? All right, okay, so the thing is, if you look at the density is mass over volume, all right, and then if I put the formula here, so here's the density, mass over volume. I'm going to do the cuboid first. It will be length times width times height. Okay, all right, so then the delta rho over rho is the density, okay, is given by, you take the uncertainty in the mass divided by the mass plus you take the uncertainty in the length divided by the length plus you take the uncertainty in width divided by width plus the uncertainty in height divided by height. Okay, now that's the way you calculate the uncertainty in this case. Okay, you may wonder why. So let me see, it's kind of crowded here, so I'm going to either delete this and show you. Yeah, let me delete this and show it again. All right, so the reason we do that is, remember, density is going to be mass over volume. Volume is length times width times height. Okay, so what I'm saying is delta rho over rho. So delta rho is going to be the uncertainty in the density. Of course, rho is the actual density, so the ratio is there, is given by delta M over M plus delta L over L plus delta W over W plus delta H over H. That's the way you calculate. All right. Now, when it comes to percent uncertainty, you always add. Even though you divide it by LW and H, you still need to add them up, because when it comes to the error, we always calculate the maximum error anyway. So you do this. If you calculate that, you can do that. Now, this is for the cuboid. Now, for the cylinder, the formula will be like this: m over pi r squared h. So you do the same thing again. So delta rho over rho equals, you do delta m over m plus delta h over h. Now plus, because we have r squared, you're going to take two of those, 2 delta r over r. Don't forget that. All right, because r is squared, so make sure you put twice, because the error is going to be multiplied in that case, so you put twice that. Anyway, that's the way you calculate that. So if you know all the values, you can calculate this, and then you can come up with delta rho, and that'll be the uncertainty, and then the way you write the answer will be rho plus or minus delta rho. Okay,